All right, what's the cube root of 27? 3. 3 to the 4th is? You said, Mr. Harris, if I didn't know 3 to the 4th, could I go to the side and work it out? Yes, yes. Number 6, how can I rewrite that using an exponent? Okay, question came up last period. Do I need to reduce that? If I reduce that, would that change the outcome of how it looks? Yes, so let's leave it n to the 4th 6, okay? How can I write number 8? 32 to the what? 1/2. Very good. Number 10, what do I need to pull out first? 2/5. Very good. And how would I write x? X to the what? Okay, and the reason we're doing this, guys, in calculus next year, you're going to have to take the derivative of something, and like that, you have to rewrite it like that before. So I'm trying to get your minds to think like that before we get to calculus, okay? Number 12, that's going to be 5x, y to the what? Very good. Are there any questions on that? Now, we're on week 4 of this. When we have a test after we complete week what?
6.
And we start week 5 tomorrow, okay? All right, number 14. Secant of 135. What quadrant is 135 in? Quadrant 2. Very good. So what's this going to be? What's my answer to 14, everybody? Negative square root of 2. Very good. I need everybody to participate. Cosine of 90. Very good. Secant of 3 pi over 2. What is the cosine of 3 pi over 2? 0. So the secant would be what? Undefined. Very good. Sine of 150. What would that be? 1/2. Very good. The sine of 300. Very good. And now I ask you the cosecant, so I just need to do what with that? Flip it, so it would be negative 2 square root of 3 over what? 3. Hold on. That's right. Okay, gotcha. Got it. Yes, buddy. Yes, you may. Are there any questions on that? Could you imagine if I just taught you this and trying to do this fast? Like if I had just taught you this lesson, like instead of reviewing it all year and waited the first day teaching you answer, could you imagine that? It would take us a long time. By the end, we wouldn't get good at it to the end of the semester, would we? But we don't have time to do that. That's why I started introducing it from day 1. You got me? Okay. All right, let's put that away. Now tomorrow we're going to start on the back. What do you think we're going to do tomorrow? We did evens day. We're going to do what tomorrow? And then do what the next day? Evens. Yep. Yes, buddy. All right, let's review our learning targets. All right. So look in here. Next Friday you have a test on all of the graphing. Okay, so we're going to review this. Graphing parent function. Okay, sine. Does it start at the origin or does it start at the end?
Origin.
Origin. Cosine starts at the what?
M.
Okay. Graphing sine by using amplitude and period. Do I need to make a table for when it's just amplitude and period?
No.
No. What is my amplitude here? Okay, how do you find the period for sine and cosine? 2 pi divided by b. What's my b value? 2 pi divided by 1 would be? How would I find my x coordinates? Take that 2 pi divided by what? Get your answer, start with it, and increase. Very good. What would this negative do right here? Reflect it, wouldn't it? Are we good on those? All right. Now, the amplitude and period is the same to find cosecant and secant, isn't it? Is everybody good with that? Okay. Now, here, involving phase shift and vertical shift, do I need to make a table? Yes. What does this deal with? Phase shift, vertical shift. What would be my phase shift here? Yes, because I see negative, but it's opposite what you think. What's your vertical shift? 3. Very good. What would I need to do with this problem? Factor out 2. If I factor out 2 out here and put it right here, what would be right here? Theta. What would be right here? Negative pi over 2. So what would be my phase shift? Pi over 2. Are we good on that? All right, here, graphing cosecant and secant. We started that yesterday. How could I rewrite this? 2 cosecant what? 1/4 theta. What would be my amplitude? 2. If this is 1/4, I say 2 pi divided by 1/4, that would be what? 8 pi. Very good. On cosecant and secant, where do your asymptotes go? Where it touches the what axis? X. Very good. And then you draw your curves. Are we good there? Okay, very good. Let's look at our homework. Number 9. My amplitude is 2. My period is 4 pi because I can rewrite that as 1/2 theta. So my period is 4 pi. I take my period, I divide it by 4, and I start with 1 pi, and I increase by 1 pi. This is cosecant, so it's related to sine. So I start a dot at the origin. Then I go up, back to my x-axis, down to my origin, so forth. Where it crosses where the dots cross, the dots are on the x-axis. Where's my asymptotes? Why are they okay? If this was okay, why are there asymptotes on those points on the x-axis? Because in the sine they were the what? They were the zeros. If this had been a sine graph, those dots on the x-axis were the zeros. So what's the inverse of the zero? It's undefined. That's why the asymptotes appear there. Does that make sense? Okay. Number 11 is secant. So this is related to which one? Secant's related to which one? Cosine. Very good. Your amplitude is 1. 2 pi divided by 2. Your period is pi. Okay. So you start up at your amp. Do your dots. Where you're going to start. You took your period and divided by 4. So you're going to start with pi over 4 and increase by pi over 4. Tomorrow we're going to have a homework check, but you know how I used to give you we're not going to do one of those homework checks where I give you a piece of paper, you do the answer. It would take too long to draw these graphs, so what I'm going to do is I'm going to walk around and you're going to show me your homework for the weekend. I'm just going to give you a completion grade, okay? Is everybody good with that? Okay. So, just on the tangent, cotangent, secant, and cosecant. We're not going back to sine. These problems, I'm going to check these problems and the problems you have tonight for tomorrow, okay? Alright, number 13, negative cosecant. You need to remember that negative, okay? Cosecant is related to sine. Your amp is 1, your period is pi. So instead of going up here, you got to start down here because that's negative. Are there any questions on 9, 11, or 13? And finally, number 15, I'm going to rewrite that as 1/2 theta. Secant's related to cosine. There's another negative, so there's going to be some reflection involved here. Amp is 2. 2 pi divided by 1/2 is 4 pi. Instead of starting up here, I'm going to start down here. Your asymptotes are going to be at your points on your x-axis. And it looks like that. Am I ever going to ask you for the domain and range? Because can you literally write the domain using interval notation? Because you can't. That's why I don't require you. Because wouldn't you have to stop at every one of these and do a union, union, union? You can't write that to infinity, can you? So that's why I don't require you to do that on these. Are there any questions? Now you could do the range using interval notation. You're not going to have to, but let's just see if you get that. What will be the range? Negative infinity to negative 2, union 2 to what? Infinity. Because it would be from here and up there. Does that make sense? But I'm not going to ask you to do that. Are there any questions? Alright. Now I want you to turn to page 9. Today our learning target is I can graph tangent and cotangent functions. And I got further than I ever thought today in first period. So we're going to shoot for that goal today, okay? I got the entire lesson done. So we will review it tomorrow. What, Connor? Got the entire lesson done. Isn't that swell? Next year in dual enrollment calculus, I did tell you we won't do math workshop next year in dual enrollment calculus.
Yeah, that's one. We're not doing math workshop thing.
Calculus takes so much. We will use that time to go over homework every day and work any problems you need for homework. And by that time, you are all doing good on ACT. By that time, we don't need to practice ACT because you're seniors. You know what I'm saying? We're about to start back practicing ACT in here.
Could you just do one semester of that?
Mm-hmm. Yes. Right now, all we're doing first semester until they approve the second semester. So. All right.
What period?
I don't know. It's either 1 or 2. 50-50 chance right now. What would y'all want it? First? First,
because that way second semester.
Second, because you can't do first. Okay. And guess what? I have no ultimate decision. That's an administrator. But when they make the schedule, they do it.
No, you just told them there's no goes with you.
Huh?
Explain that's for. Like if I get it as far as go get it in section, and then you call it, so they don't have it. That's good.
Everyone's going to be too tired.
But first period is longer to me, in my opinion.
I'd want first.
But what do you have? You have the. Yeah. I know. All right, so let's look here. Graphing tangent and cotangent. Graphing tangent and cotangent. So we're going to look at the parent functions for a minute. Now, just like secant and cosecant, they do involve isotopes because there's undefined areas, okay? So right here it says y equals tangent of x. Get off that phone. All right, so on these, I want you to take each one of these and plug it in. Now, this threw some people for a loop first period. So let's just hold on. Watch me. Don't do anything yet. In a minute, you're going to fill out this chart and this chart, okay? This is tangent and this is cotangent. How do you define tangent? Y divided by? How do you define cotangent? Okay, so I asked people to fill in this chart and they went, I don't know what you're talking about. Okay, I'm taking this x value and plugging it in. It's just tricky Tuesday you're evaluating. What is tangent of negative pi over 2? That's down there at 270, isn't it? So your ordered pair is 0, negative 1. What's negative 1 divided by 0? So what would you put here? A u. You see that? Wait, don't yet. For undefined.
Oh, okay.
Now, if you want to write the word undefined, you can. Tangent of negative pi over 4. Where's pi over 4 at in quad what? Where would negative pi over 4 be in quad what? 4. So, you know pi over 4 is easy because it's the same digits, both coordinates, is it? So, is it positive 1 or negative 1? So, I would put a negative 1. Tangent of 0. What's your ordered pair for 0? 1, 0. So what would be your tangent of 0 value?
0.
0. Do y'all see what I'm doing there?
Yeah.
You're just evaluating. When we do those tricky Tuesdays, you're evaluating those. That's what you're doing here. Does that make sense? Are you sure? So can you fill out the rest of the chart for me?
Yes.
And do the cotangent. Go ahead, Mr. Hall.
Why are we starting the negative on this chart?
I'm going to show you in a minute. Just do it right now. So you're going to evaluate tangent of pi over 4. 1.
I just need to see how everything works. Okay. Because every day I have to turn it when I come in.
Oh,
I'm so confused.
right here. It goes on that X right there.
Okay.
Okay. You can work in your group. If you're still confused about what I'm doing, you can talk in your group. I need you to figure this out and cotangent out. Does that make sense?
Pi over 2 would be
Huh? I think that's a major point, so what's your coordinate? Yes. 2 more minutes. What did you do? I can just look here again. You're guilty.
Would it be negative 2 over 2? So it's negative 1 for...
That's why I have no idea.
Didn't it? Okay, he didn't know what y'all helping him. No, not that. Just like, you know how you do 5 problems? Tangent of 3 pi over 4. What quadrant is 3 pi over 4? You go 2.
I'm not going on the slide.
Which one's positive, which one's negative?
Y, no, X is
Tangent is y divided by x, so what be your guys? Pi is a major point.
So it does go.
I know, but you're going to evaluate it. Don't just go by that.
You should know why it's something.
Right, I know why it says numbers now, but like, I wasn't gonna keep it out of
All right. What is pi over 2, guys? Everyone. 3 pi over 4.
-1.
Pi.
0.
5 pi over 4.
1.
3 pi over 2.
5.
7 pi over 4. 2 pi. Very good. Now, guys, what I'm going to do is I am going to graph these, okay? At negative pi over 2, it says undefined. So I'm going to put an asymptote. Very good. Now, you said, Mr. Chair, I don't see where negative pi over 4 is at. Okay, let's use some common sense here. If this is negative 1/2 and this is 0, wouldn't that be in between those? So I'm going to put negative pi over 4 there. And that's going to be negative 1. About right there. 0, 0. Pi over 4 is right here. Asymptote at pi over 2. 3 pi over 4. Pi. Seven pi over 4 is negative 1 right here.
Where do you? I'm confused on where you put the points, or where you get the points that you're.
Okay, just a second. Guys, I need to make sure now that we're plotting points and we're filling in a table. I got to make sure everybody understands this. All I did up at this table was this was my x values. I plugged it in and I evaluated my trig functions like we do on Triggy Tuesday. Do we understand how I got the table now? Next, these are ordered pairs. Negative pi over 2 and undefined. You can't plot undefined. That's just an asymptote at negative pi over 2. Negative pi over 4 and negative 1. That's my x coordinate. That's my y. So I went to negative pi over 4 and went down 1 on my y coordinate. 0, 0. Plotted that. Pi over 4, 1. Pi over 4, up 1 unit. Pi over 2 was undefined, so there's an asymptote. 3 pi over 4 is right there. Come down to negative 1. Pi comma 0 is pi 0. Does that make sense now?
Yes, sir.
Are we good? Okay. Let's talk about this. We need to look at some characteristics of this paragraph. You're not going to have to graph the parent function at any time. We just need to learn some stuff from here. Okay? Does it go through the origin? Yes, you need to know that. In a minute you're going to learn cotangent does not. So tangent does go through the origin. Okay, so you say, okay, Mr. Chester, what is the significance between these two asymptotes? The area between two, pay attention to me. The area between two asymptotes is 1 cycle. So if I ask you to graph 2 cycles, I'm going to have 3 asymptotes, aren't I? Because I got 1 here, and then I got another set here. So it's 1, 2, 3 asymptotes. Because that would be 2 sets of asymptotes with it. Does that make sense? Like right here, this is 1. Like right here, that would be 2 cycles because I got an area here and an area here. Do you see that? All right, so you upset? Heartburn or something? Okay, you good? Okay. All right. Now, you made me lose my thought here.
Oh, you're saying,
2 cycles. Thank you.
yeah.
All right. So, in order to graph tangent, okay, in sine and cosine, you had to have an amplitude and period to graph. In tangent, cotangent, you're going to have a period and asymptotes. You don't really have amplitude. You don't have amplitude because these graphs keep going, don't they? Okay. So, the period, okay, what was our period for a parent function for sine and cosine? 2 pi. 2 pi. The period for tangent, cotangent is pi. Okay. The asymptotes are at the end of the cycle. Of course you're going to ask me that. ASYMPTOTES. Okay. Now, here's something very important I'm about to put here. How do you find the period for sine, cosine, cosecant, secant? 2 pi divided by what? Okay, here's how you find it for tangent. Pi over b. So there's your period formula. It's pi over b. It's not 2 pi, and that is directly related to what we just put down here. So I told you you're going to need 2 things, period and asymptote. So here's your asymptote formula. Plus or minus 1/2 times the period. And that is how you find your asymptotes. So that is very important. You take your period and times it by plus or minus 1/2. No, we're going to get there in a minute. Cotangent is even easier than that. Okay, what do you think the range is on this?
Negative infinity to positive.
Very good. All real numbers. Negative infinity to infinity. Now, the reason I require you to write the domain, could you write the domain using interval notation in this case? No, because what would you have to do? At every asymptote, you would have stopped, put a union, and keep going, wouldn't you? And you can't write that for infinity, can you? So the best thing you can do for this is put x cannot equal pi over 2 plus n pi. You're not going to have to remember this, but I just want to explain what this means here. If you notice, where's the asymptotes occurring for the parent function? At every what point? Half, isn't it? So that's why you got a half to begin with. But you say, what does that plus n pi mean? Okay, if I have a half and I add 1 to it, that gives me 3 halves, don't it? If I add 2, that gives me 5 halves. If I add 3, it gives me 7 halves. So that n pi means n is for some integer. Does that make sense? But that's the only way you can write the domain there. And but that's what that means if you ever see that. That means for every half and the multiple of that half. So key things you need to take out of this. The shape of the graph. See how it goes like that? You need to know that. Does it go through the origin? Yes, for tangent. Now, okay, I'm going to get that in a minute. Period formula, pi over what? Asymptotes, plus or minus 1/2 times the period. Okay, that's the things you need to know. And that's going to make sense when we get down here in just a minute. Alright, let's do cotangent. Let's go across. What's the cotangent negative pi over 2? 0. Everybody, negative pi over 4. I'm going to say it again. Key word there. Everybody. 0, what is it? Undefined. Now, let's stop there for a minute. If it goes through the origin on tangent, that means it's a 0, isn't it? So it would have to be undefined because the reciprocal of 0 is 1 over 0. Does that make sense? Okay. Pi over 4, what is it? 1. Pi over 2? 3 pi over 4? Pi? Undefined. 5 pi over 4? 3 pi over 2? 7 pi over 4? 2 pi? Very good. Let's graph those. I'm going to graph negative pi over 2. That means a point there. There's an asymptote at the origin. You need to know that. The shape is just backwards, isn't it?
Mm-hmm.
Yep. The period is the same. It is pi. The asymptotes are at the end of each cycle. The range is all real numbers, just like cotangent. But where's the asymptotes occurring now? In tangent, it was pi over 2. Where's it occurring on this one? At multiples of what? Pi. So I will put x cannot equal pi. I will just put n pi. Because n pi takes care of 0. 1 times pi is pi. 2 pi, 3 pi, and all that. Now, to find the period of cotangent is the same as tangent. Pi over b. Asymptotes. I'm going to stop right there. I'm going to let you take a breather. Get caught up. What do you think one of the asymptotes is always? 0. It will always be an asymptote at 0. So your asymptotes for cotangent 0, and the other is plus or minus the period. So those are the formulas you need to realize. So from this graph, you need to realize there's always an asymptote at 0. Your period formula is the same, but for the asymptotes here, it is 0, comma, plus or minus the period, okay? Up here, the asymptotes for tangent is plus or minus 1/2 times the period. Are there any questions so far? Alright, in the bottom part, we're just going to do the period and asymptotes. We're not graphing these. We're just going to do the period. What type of function are we doing on number 1? Is it tangent or cotangent? What would be my period there, guys? Pi over 3. Now I need my asymptotes. I'm going to abbreviate asymptotes. How do you find the asymptotes for a tangent? You take your period and times it by what? Plus or minus 1/2. So what's 1/3 times plus or minus 1/2? 1/6. So it would be plus or minus pi over 6. So you took your period, which is 1/3 times 1/2 plus or minus 1/6. Does that make sense? Which function are we dealing with here? Tangent. Okay, so what's your b value there? I could rewrite that as what? 3/4 x. So if I take 1 pi and divide it by 3/4, what's going to happen there? It's going to flip, isn't it? So what will be your period? 4 pi over 3. Because 1 divided by 3/4. To find your asymptotes, you say plus or minus 1/2 times the period. So I say 1/2 times 4 pi over 3. That gives me 4 pi plus or minus 4 pi over 6. Can I reduce that? So your asymptotes would be at plus or minus 2 pi over 3.
And then 0 also?
No. What are we dealing with here? Tangent. Now 3 and 4 deals with cotangent. To me, those are even easier. What's your period for number 3? Pi over 2, because your b value is 2, so it's pi over 2. Now here, your asymptotes, what's always the first one? 0, and then plus or minus your period.
So the cotangent is always just plus or minus the
Period.
Oh, that's not bad.
Tangent is when you got to multiply by plus or minus 1/2. Cotangent, what's my period here? 3 pi over 4. Your asymptote would be always what's first? 0 and then what? Now let's graph those. That's the hardest part right there. If you know how to do that, you're good. That's as hard as it gets. Now we're not doing all these. We're going to start with number 5 and number 8 first. period. Period. I got, what's my period going to be on this? Pi over 2. Pi over 2. Alright. Now, for a tangent, you take your period and multiply it by what? Plus or minus what? 1/2. So, plus or minus 1/2 times pi over 2 would be plus or minus what? Pi over 4. Plus or minus pi over 4. That's all the information you need to graph it. So before we start, do we understand how I calculate the period and the asymptotes?
Yes.
Okay. What you always graph first, because I don't want you to memorize something, I want you to understand it. I want you to graph first is the asymptotes. So we're going to graph plus or minus pi over 4. Now remember, tangent. There was always a what at the origin? A dot, wasn't it? Okay, for tangent. So where would be positive pi over 4? Would be left or to the right of the origin? To the right. And negative would be to the left. And those would be my asymptotes. You look at that. How many cycles do I have there?
1.
I need how many? 2. So I need like another dot here, and I need another asymptote, don't I? So I already put the dot here. That's easy, but the hardest part is figuring out what goes there for that value and what goes there for that value. How do you think we could do that? From here to here is how much distance? From this to this is how much distance? Pi over 4. So how am I going to get from here to here? Add another pi over 4, wouldn't I? Does that make sense? From here to here is pi over 4. Won't it increase by the same interval? So if from here to here is pi over 4, what would this be? 2 pi over 4, which is pi over. And this would be what? 3 pi over 4. And then just draw your line and you're done. He said, Mr. Chester, how is the period pi over 2? Let's just test it. Let's take this phase shift right here. This period. Between these two asymptotes, what's 3 pi over 4 minus pi over 4? Pi over 2. Isn't that the distance of one cycle? If you said 1/4 minus a negative 1/4, that's a double negative. That'd be 1/4 plus 1/4, which will be 2/4, which is what? So does that make sense? Okay. Let's look at cotangent. Number 8. What would be my period here? Pi over 4. What is always your first asymptote for cotangent? And then it's going to be plus or minus the period, which is plus or minus 4. Always graph your asymptotes first. So I got one going through the origin. I graphed that. Do I need any more asymptotes? No. I have my 2 cages. I call it the cages right there. You got your 2 areas. What is it that I need to find? I need to find something here and something here, don't I?
Where do the points are?
The points are. How would you go about doing that?
Add 1/4? Or no?
Okay, it's like the midpoint between these 2 points, isn't it? So how would I find that? If the distance from here to here is this, I would take this and do what? Divide by 2.
Pi over 8.
Pi over 8. So pi over 8 would be right here. Negative pi over 8 would be here. And then you're ready to draw. Do you see why I want that to make sense to you? Instead of trying to say, okay, what do I do with tangent? Draw it and look at what you have there. If you got enough asymptotes, you don't need any more. You just need to find that middle point. But for tangent, you have one asymptote, you got to keep going. Does that make sense?
Does it matter which way they go?
Yes, it does. Tangent goes this way. Cotangent goes this way. That's what we're going to do number 7. Let's look at number 7. These are quick, so we'll get time. Number 7. You see that negative outside from that tangent? What is that going to do with it? Reflect it. So in this case, what is it going to actually look like? A tangent or cotangent? You would draw it the other way. Alright, so what's my period here? Pi divided by 1/3 is what? 3 pi. So I take plus or minus 1/2 times 3. So my asymptotes are at plus or minus 3 pi over 2. My period is 3 pi. My asymptote is plus or minus 3 pi over 2. What do we always graph first? Asymptote. So this is 3 pi over 2 and negative 3 pi over 2. And because this is tangent, will there be a point at the origin? Yes. You draw it in opposite direction. Now, how many cycles do I have? How many periods do I have? 1. I need to find another asymptote over here, don't I? Do I need to increase or do I need to divide something? Increase from here to here is a distance of 3 over 2, isn't it? What's 3 over 2 plus 3 over 2?
6 over 4.
Nope.
Oh God, my bad.
6 over 2. Okay, we got that. 6 over 2. What does that reduce to? 3 pi. So 6 over 2 plus 3 over 2 would equal what?
9 over 2.
So what would be right here? 9 pi over 2. Do you see that? I said 3 pi over 2 plus 3 pi over 2 is 6 pi over 2 plus 3 pi over 2 is 9 pi over 2. What now? In this case, in tangent it does, but I don't want you to think of it like that. I want you to think as increasing. Yes. One more. Number 9. You see a negative cotangent. What is that going to actually look like? A tangent. Pi divided by 1/2 is what? 2 pi. What's always your first asymptote? And then it's going to be plus or minus the period. So I'm going to put an asymptote at 0. Asymptote at 2 pi and negative 2 pi. So do I have enough asymptotes in this particular one? I just need to find a point to put that dot on. How could I find that point? Divide 2 pi divided by 2, which is pi, negative pi, and then you draw your graph. You have 6 homework problems, 1 through 4 on page 19, same page as last night, deals with tangent and cotangent, and numbers 10 and 12 deals with secant and cosecant. Have a great day.
Can I do,
Y'all too.